As you can see up on the board, we're going to be talking today about how do we take a complex number and raise that to a power, or take a root for that. So I've written up there a couple of them in rectangular form, a couple of them in polar form. These are the kinds of problems we're going to be talking about today. We know how we would do it if it's in rectangular form, but if it really was a plus bi to the 15th, that would be a tedious problem, to say the least. We'd have to take a plus bi times a plus bi, and then we could take that times itself, and that would have been to the 4th power, and we just have to keep foiling over and over until we finally had used all 15 terms to get to our answer. We're going to see today that if we change that to its polar form, DeMoivre's theorem is going to give us a much easier way to raise that to a power. And right now, we don't have any way of taking a root, like the 7th root of a complex number a plus bi. We have no idea what that would be. And DeMoivre's will let us do that for one that we have in polar form. So as we get started, since we're going to be multiplying complex numbers by complex numbers when we take one and raise it to a power, let's make sure we remember what we already know about how to multiply two different complex numbers. If we had to, like you see up here on the board, we would multiply the magnitudes, so we'd have R1, R2, and then we would add the angles together, so we'd have theta 1 plus theta 2. If those happen to be the same thing, instead of R1 times something different, it's going to be R times R. So we'll have an R squared. Instead of adding two different angles, we're adding the same angle to itself, so we have 2 theta. If we wanted to raise it to the 3rd power, we just take what we had right here times another R cis theta, and if we multiplied the magnitudes, we'd have R cubed, and if we added 2 theta and theta, we'd have 3 theta. And so on and so on. Are you starting to see the pattern in there? So if we want to take a complex number in polar form and raise it to a power, we're going to take the magnitude to that power, and then we're going to have cis of, and then that power times the angle. And that is DeMoivre's theorem. However, the catch is it must be in polar form to use DeMoivre's. Rectangular form, we don't have a nice little shortcut for that. One of these today I will actually do both ways, the long way of foiling a whole bunch and using DeMoivre's, just to show you that we do indeed get the very same answer either way. You are going to want to read your directions carefully. Did they tell you to leave it in polar form or change it to rectangular form? But you should be used to that by now. You've had enough other problems where they have been asking you to do that. So get the complex number in polar form, and then if we want to raise it to a power, we take the magnitude to that power, cis of the power times the angle. So I want us now to give this a try here. Let's see if we can use DeMoivre's to take 3 cis 25 degrees to the 4th power. So help me figure out how to get started here. It said I do what with the 3? To the 4th, and what do I have to do with the angle? Multiply, because I'd be adding 25 plus 25 plus 25. So let's see, 3 to the 4th, 3 times 3 times 3 times 3, isn't that 9 times 9? So 81, and cis of 100, and this did not say I had to change it, so I'm just going to leave it in polar form. That was really nice and easy. It was already in polar, and I got to leave it in polar. Next one's not going to be so nice, though. I'm never that nice to you, right? We always have to do some that are more complicated. Okay, this one we're actually going to end up doing it both ways. Right now it's in rectangular form. So on the next slide, I'm going to do 3 minus root 3i times 3 minus root 3i times 3 minus root 3i times 3 minus root 3i. Just with foiling as much as I have to get there. This one, though, I want us to use DeMoivre's, but we can't use DeMoivre's right away. Why not? We've got to get it in polar, so we begin with our sketch so we can get our angle correct. Many of you are making mistakes because you are trying to skip your work. This needs to be in the fourth quadrant. So I need, let's see, help me out here. That means r needs to be the square root of 3 squared plus root 3 squared. So what do I have here? 9 plus 3, so root 12 or 2 root 3. Okay, and then for my angle, no calculator, because you don't need it. For my angle, then I have inverse tan root 3 over 3. Don't I know that on my unit circle for tangent? Yep. So what angle am I at? Negative 30, but let's put that positively as 330 degrees. So what we have said so far is 3 minus root 3i is 2 root 3 cis 330 degrees. Yes? Okay, is that what this problem asks me for? Does it ask me for 3 minus root 3i? It asks me for 3 minus root 3i to the fourth. Now I can use DeMoivre's, and I can say that that is 2 root 3 to the fourth times the cis of 4 times 330. So 2 to the fourth is how much? 16. Root 3 to the fourth. 9. So I've got 16 times 9, which is 144. Cis of, let's see, 4 times 3 is 0. 4 times 3 is 12. 4 times 13, 20? Yeah. That is more than once around the unit circle. So I need to convert that so I know what in the world I'm doing with it. So let's see, once is 360, twice is 720, 3 times is 1080. I think that's, if I go another time, I'll be past the 1320, right? So what is 1320 minus 1080 going to give us? 240. Is that an angle I know? And now it wants my final answer in rectangular coordinates. So that means 144 cosine 240 plus 144 sine 240 times I cosine 240. What's that going to be? Aiden, what's that going to be? And sine 240. What is that going to be? Anna? And let's see, 144 divided by 2 is 72, so negative 72 minus 72 root 3i. So the DeMoivre's theorem part was relatively easy. Most of our time was spent converting between polar and rectangular on this one, right? But DeMoivre's made the actual calculation of the power relatively easy. Do we have to use DeMoivre's? Like, unless it's only to the fourth, so we're going to do this one manually next. And in general, to answer your question, if the directions say use DeMoivre's, you must use DeMoivre's. If they just say find this power, then it's your choice. And you're right, you're on track with it may be easier to FOIL it out if the power is small than to do the converting back and forth. So read the directions, and then if it is your choice, think about, well, which one would be easier on this problem? So let's try this same one by expanding it out. And so it's 3 minus root 3i to the fourth. So 3 minus root 3i to the fourth. That's going to be 3 minus root 3i times 3 minus root 3i. And once I get that, I'm going to have to multiply that whole thing by itself. So let's FOIL. 3 times 3 is 9. And then I've got 2 of the same thing, so minus 2 times 3, so minus 6 root 3i. Did I get that part right? And then last times last, minus minus is plus. Root 3 is a regular 3i squared. But I squared is how much? So that's really a minus 3, so that's really a 9 minus 3, which is 6 minus 6 root 3i. And then I have to multiply that by itself again. So far, are we okay? Okay, so then let's see, 6 times 6 is 36. And then I'm going to have minus 36 root 3i and another minus 36 root 3i, so minus 72 root 3i. And then last times last will be minus minus is a plus. 6 times 6 is 36. Root 3 is a regular 3, and that's going to be an I squared. So I do have my minus 72 root 3i, just like I had before. Let's see if we can get the minus 72 for the real part. So let's see, I squared is the negative 1, right? And let's see, if I multiply these, 3 times 6 is 18, 100, so I really need to subtract 108. What is 36 minus 108? So we do get the minus 72 in there. We got the same thing both ways. Anybody comfortable with how that worked? Okay, integers are not the only things that we can have as exponents. If we want to take roots, we can think of the square root as z to the 1/2, the cubed root as z to the 1/3, right? And as long as we write our roots with fractions for the exponents, we can still use DeMoivre's. We will have r to the 1/2 when we're doing the square root, cis 1/2 times theta. For the cubed root, I will have r to the 1/3, cis of 1/3 times theta, and so on. But there's going to be a catch. If we just take something to the 5th power, or the 12th power, or if we just square it, we will only get one answer. But let's think about roots for a minute. And we know that when we've been solving equations and we get to the step where we take the square root of both sides, what do we have to remember to do? Plus or minus, because we know if we've got 16, that there really are 2 numbers we can multiply by themselves to get 16, positive 4 and negative 4. So with square roots, we kind of get what we're talking about with there being 2 answers. With cubed roots, there are going to be 3 answers. 4th roots, there will be 4 answers. 5th roots, there will be 5 answers, and so on. The way we get these with DeMoivre's is we are going to get the first one, and if they are square roots, they're going to be half a circle apart, so we're going to add 180 degrees. If they are cubed roots, that means we've got 3 of them as we go around the circle once. So we need to take 360 divided by 3 to get 120. So we're going to add 100, and we're going to take the first one, add 120, add 120 again to get those equally spaced around the circle. If we want fourth roots, we have to take 360 divided by 4. So we get the first one, add 90, add 90, add 90, until we have gotten all 4 of them. If there are n roots, we're going to take 360 divided by n. And what students have trouble with every year, powers, there's only one. It's only when your exponents are a half, a third, a fourth, a fifth, that we worry about having more than one answer. And I want to do an example with you in a moment of how that is going to work. So I'll do a couple of examples here. So if I want 3 cubed roots, I'm not taking this to the power of 3. I've got the exponent of a third. This one's going to be nice, easy, fast, because it's already in polar form. So I want 27 cis 135, and I want to take that and take the cubed root of it. So I'm still going to use DeMoivre's. It will be 27 to the exponent 1/3, and it will be cis of the exponent times the angle, so 1/3 times 135. So, K, what's the cubed root of 27? And 135 divided by 3, Emily-Ann? That is my first of these roots. It's okay to leave it in polar, so that part's nice. Because they are cubed roots, to get the other 2, I need to add 360 divided by 3. So 145 plus 120 is 165, so I have 3 cis 165. And 165 plus 120 is how much? 285. And if I added 120 again, I'm not going to because I have all 3 of them, I would then be at 405, which is the same location as 45 degrees. Questions on that one? And before I do the very last one, I want to review something with you guys that trips people up every single year when we try to do these. If we are converting to polar, and it's one of our quadrantal ones, it's one of the ones that's going to land on an axis, let's think about how we convert these. So I want everybody point left, right, up, or down. Where does 5i go? So great, 5i goes straight up because horizontal is the real axis, vertical is the imaginary, so this one goes straight up. What is our angle for that? Do I want positive or negative 5 cis 90? Positive, because I'm actually going that direction. Okay, now everybody point, where does minus 4i go? Okay, that one goes straight down. So how many degrees is that? So I'm going to have something cis 270 degrees, right? Do I want minus 4 cis 270 or plus 4 cis 270? Plus 4. Because if my angle is 270, if I put the minus 4, that's going to flip it and it's really going to be going straight up. And that's different from this problem. So when you are doing these that have minuses on them and you're taking roots, this is always going to be a positive thing you're taking a root of. So keep that in mind. Now we want to do 4 fourth roots of negative 16. And then we're going to get them in rectangular form before we're finished. So, negative 16, everybody point for me. Where does that one go? So that's going to go to the left. So how many degrees is that? Negative 16 cis 180 or positive 16? Positive, because if the angle's going over here to the left, if we put a minus in front of that, it's going to mean it's really going to the right, and it's not supposed to be. So when it's a minus something, it's still going to be a plus when you write it this way. The problem did not say what is negative 16 in polar form. The problem says what is the fourth root of that, which means 16 to the 1/4 cis of 1/4 times 180. Fourth root of 16, everybody. And what is 1/4 times 180 going to be? That is my first root. So choose cis 45 degrees. I'm going to need to get it into rectangular form before I'm finished. How much do I need to add to get my other roots? Why 90? So 360 divided by 4, since we're doing fourth roots. So we're going to add 90. What is 45 plus 90? Plus 90. And plus 90 one more time. So there are our 4 in polar form. So now I need to know what is the cosine of 45 degrees? Root 2 over 2 and the sine? So that means we have root 2 plus root 2i for our first root written in polar form. Okay, if I am in second quadrant, 135, tell me about the cosine and the sine. So cosine's negative, sine's positive. So we have minus root 2 plus root 2i. Read, third quadrant, tell me about sine and cosine. So this time they're both negative, still the root 2's over 2's. So now we have 2 times minus root 2 over 2 plus 2 times minus root 2 over 2 times I, giving us minus root 2 minus root 2i. And finally, fourth quadrant. Natalie, tell me about sine and cosine. So the cosine is positive root 2 over 2, sine is negative. So we end up with root 2 minus root 2i. And I'm going to be picky on your work. No plus minus combination signs on these. I want to see that you understand the 4 different roots that you've gotten. And I want them in the order that you'd go around the circle. The 45, then the 135, then the 225, then the 315. I don't want these jumbled in some different order. I want to be able to easily check your work. Any questions on DeMoivre's? The messiest part is the polar rectangular conversion. DeMoivre's itself is actually very nice and simple.